Welcome to the lesson on classifying polynomials. But what is a polynomial? A polynomial is an expression consisting of variables and coefficients where terms are separated by addition and subtraction. Let's take a closer look at some of the words used in that definition for polynomial. First is the word term. Terms are a product, which means a multiplication, so a product of numbers and variables. Okay, a product of numbers and variables. So there are no addition and subtraction signs. They're all going to be multiplication. So something like negative 2xy is an example of one term. If I added a 3x onto it, this is now two terms. First term would be the negative 2xy, and the second term would be the positive 3x. Next is coefficient. Coefficient is what we call the number that is in front of the variable. So it's the number that's being multiplied by the letters. So in the example above, from negative 2xy, the negative 2 is the coefficient in that particular example. If I was looking at the 3x, the positive 3 is the coefficient because that's the number in front of that variable. Standard form is our next vocabulary term, and this refers to when the polynomial is in when the terms are in decreasing power, so highest to lowest. We can't really use the negative 2xy plus 3x as an example because they don't have any powers on them. They don't have any exponents other than 1. So another example might be like let's say negative 2x squared plus 3x. So if I got rid of the y and just made it a negative 2x squared, this would be considered standard form because the squared is in higher power than the first power on the x. So that would be considered standard form when the terms are in decreasing power order. One final word to define in this particular section is the degree. And the degree of a polynomial is the highest power that the polynomial has. So the highest power on the polynomial. And so if I go back to the example on the previous screen with the negative 2x squared plus 3x, I referenced about how the 2 is a higher exponent than the 1 over here, so this would be in standard form, and that is correct. So this expression is in standard form. 2 is the highest power, so this would be a second degree polynomial. So the degree on that example would be a 2. Now what we're going to be moving into next is how some of these polynomials have special names, which is what classifying them is all about. Some of these polynomials have special names when they have a certain degree or a certain number of terms. So that's what we're going to move into next. First name based on the degree would be a constant, and that's when the highest power is 0. So what does it look like to have a highest power of 0? Well, that really means that there's no variable at all. Like if I have 3x to the 0 power, we remember from our exponent rules, anything to the 0 power is just 1. So that's really saying 3 times 1. So 3x to the 0 power is really just 3. Simplifying things completely, guys. The constant is just the number, no variable. Okay, that's what it means to be a constant. And that's why when we have a long expression, the number without a variable is called a constant because it's never going to change. That 3 is constantly 3. So if the highest power is 0, that means there is no variable and it's just the number. That's called a constant. Linear is when the highest power is a 1. This is what we have been doing over and over again with our graphing our lines, both equations and inequalities. The highest power on that variable has been 1. So something like, your mx plus b form, 2x minus 4 is an example of linear. It could just be negative 2/3 x. It doesn't matter what the coefficient is. It doesn't matter what the number in front of the variable is. It matters that the highest power on that x is a 1. Constant in this first example here would be the -4. That would be the -4. So there are 2 terms in this example. It's the highest power of the x is 1, so it's called a linear polynomial. Quadratic, as you guessed it, highest power on the x is 2. So quick example, just negative 2x squared plus 5x minus 3 would be an example of a quadratic polynomial. The highest power on the x is 2. It does not matter that there's a 1 here or that there's an x to the 0 there on that constant. It also does not have to be 3 terms. We will talk about that when we classify by terms. But right now, the highest power on that example is 2, so it is considered a quadratic. Cubic is the highest power is 3, so keeping it simple here, 3x cubed is a cubic polynomial. The highest power is 3. I understand it's not very long. We could keep going if we wanted to, minus 6x plus 2. You don't even have to have an x squared in there. You can skip around. But that is the highest power of x is 3. Technically, just to review, this is in standard form because the highest power is first, and then the next highest, and then the next highest. So we do always try to write in standard form just to make sure that we're consistent and neat and not missing variables whenever we go along. So that's a cubic function. We call a polynomial where the highest power is 4 with a 4th degree polynomial is called a quartic. So an example of that might just be, negative 7x to the 4th plus 2x cubed minus 5x. And again, I'm just running out of space. We could keep going. I could even make that an x squared, so it kind of goes down in order. That is standard form. It's a quartic because the highest power on the x is 4. Last one for a cute little name for being classified by degree is a quintic. That's when the highest power is 5. So 9x to the 5th minus 3x squared. I don't know, let's make it like plus 7. There's an example of a quintic where the highest power on the x is 5. Again, it's in standard form. And this does not mean from here on out that you can't have anything higher than that. We can have polynomials where there's a 6th degree, where it's x to the 6th power, x to the 10th power, x to the 20th power. Those do exist, they just don't have cute names. These are the only ones that have cute names. Constant, highest power of 0, linear, quadratic, cubic, quartic, and quintic. So when the powers go from 0 to 5, they have cute little names and we can classify them. The other way to classify polynomials is by the number of terms. Monomial, binomial, and trinomial are the only 3 choices we have for cute names, for cute classifications with polynomials by the number of terms. A monomial is 1 term. Mono, that prefix there means 1, so it's 1 term. An example of that could just be a constant, like the number 3. It might be negative 2x. Those are monomials. I understand that there is a number and a variable here, but this is 1 term. Remember, a term is a product, so it's negative 2 times x. This is a single term. This would be a monomial. This constant is also a monomial. For 2 terms, I could put them together. I'm going to put it in standard form, though. Negative 2x plus 3 would be a binomial. We could also have another example of maybe like 5x to the 6th plus 7x. That would be 2 terms. It's a product and a product that's separated by addition or subtraction. Either of those could be subtractions as well. A trinomial example with 3 terms would be something like, 5x squared minus 2x plus 6. So there are 3 terms. Now you want to make sure that they are in standard form. And then just some other vocab things to talk about quickly as we go through these examples. 5 is called a leading coefficient because it is first. So the 5 is the coefficient that's leading. The -2 is also a coefficient because it is the number in front of a variable, but it's not the leading coefficient. 5 is up front, so it's the leading. This 6 on the end is a constant because, again, there is no variable. So this is a trinomial. Technically, it's a quadratic trinomial because the highest power is 2. 3 terms is trinomial. It is in standard form. Leading coefficient is 5. So in this single little problem here, we have a lot to classify from and a lot of information and vocab to look at.
Last thing we're going to do here is take a look at some examples. Pretty much what you're going to be asked to do from this lesson is to be able to classify by degree and number of terms. Sometimes it'll just be degree, sometimes it will just be number of terms, and again, sometimes it will be both of those things. So when you're looking at the degree, again, that's the highest power. The number of terms would be what those things are that are separated by the pluses and minuses. So the first one, negative 2x plus 3, there's 2 terms, so that makes it a binomial. And the highest power on the x is a 1. So this is a linear binomial. And I know that I counted the number of terms first, and then I put the degree, actually naming it first, but that's really how we do it. It's the degree first, and then the number of terms. So it's a linear binomial. Second one, just by looking at it, it's definitely a binomial. The highest power is a 6. We do not have a special name for this. So this is just called a sixth degree binomial. So that's a good example of one where we don't have a cute little name for something where the highest power is 6, but we just call it a 6th degree binomial. Next one we already talked about on the previous slide. This is a quadratic 1, 2, 3 trinomial. So the quadratic is coming from the fact that the highest power on the x is 2, and the trinomial is coming from the fact that it has 3 terms. Last one, 1, 2, 3, 4 terms, and if you look, I know it may seem like that 3 is going to be the highest power, but it's actually this 5 because this example is not in standard form. So this is a quintic, and quintic is coming from that 5th degree. It's a quintic 4-term polynomial because the 4 terms does not have a cute little name. We only have monomial, binomial, and trinomial. We don't have anything for 4 terms, so it just becomes a 4-term polynomial. Again, quintic because the highest power is actually on the 5 there. And so remember, standard form actually puts that first. So we should really be rewriting this as negative 5x to the 5th plus 3x cubed plus 2x plus 1. That would put it in standard form. Highest power, then the next highest, then the next highest, and so forth. Leading coefficient would be negative 5. The other coefficients are a positive 3 and a positive 2. And the constant in this example is 1. So just a couple of review on some of that vocab there. So I hope this helps. Please make sure that you use this video to fill out the vocab assignment. Thanks.